Hello and welcome to another video, this time on mechanics, paper 2020, question 1, and it was a planes and forces question. A rough plane inclined at an angle. So this time they wanted you to draw it yourself. Well, good, you know, it's about time they asked a question like that. You know, diagrams are everything in this, and so get the students to draw it themselves. Okay, there's bound to be a block on it. There we go, a brick P of mass M is placed on the plane. So that'll be mg. And that angle here, parallel and perpendicular to the plane, will be alpha, and you'll have a contact force R. Yeah. Now it's rough, so we need to figure out which way the friction is going. It's on the point of sliding down the plane, so friction must be going up the plane. And is it in? Yeah, it's on the point of sliding down, so that must be a maximum. And that is pretty much it. So find in terms of energy the magnitude of the normal reaction on brick P. Well, let's do the prep work. If tan alpha is 3/4, then sine alpha is 3/5, and cos alpha is 4/5. Where am I getting that from? Draw a quick little triangle out with that as alpha, and as its opposite divided by adjacent for tan, that would be 5 by Pythagoras, and you can see it's 3/5 and 4/5. Okay, so find in terms of energy and magnitude of the normal reaction. Well, R is simply going to be equal to mg cos alpha, and so in this case that will be 4/5 mg. That's that part of the question done. Okay, show that mu is 3/4. Well, F max is mu R, but F max also equals mg sine alpha because it's in equilibrium, and so F max is of course 3/5 mg, and therefore F max is mu R. That's what I'm going to use next, and so 3/5 mg is mu times 4/5 mg. The mg's cancel, the fifths cancel if you like, and mu ends up being 3/4. Done. Okay, parts C and D. You're not required to do any further calculations. Well, that sounds like a bonus. Don't have to do any maths in parts C and D. Okay, brick P is now removed from the plane, and a much heavier brick Q is placed on the plane. Coefficient between Q and the plane is also 3/4, so mu hasn't changed. Explain briefly why brick Q will remain at rest on the plane. Okay, so why does it remain at rest? Because, I mean, there's this there's this kind of a common misconception in mechanics that heavier objects fall faster and want to fall more. Obviously that is actually untrue. Galileo proved by dropping heavy bricks off and light bricks off the top of the Leaning Tower of Pisa, which were exactly the same shape. He proved that they fell at exactly the same acceleration. So, you know, that's something you want to get out of your head. But the forces on Q still balance, yeah? Forces on Q still balance. Did you notice before that the m's cancelled? Yeah. In other words, it's nothing to do with the mass and the fact that it's heavier. Yeah. Like the mg, which is the weight of, you know, weight of the object, that cancelled to find mu, and so, you know, everything's still going to be exactly the same. So the way I put it, the forces on Q still balance, as in the previous working the mg's cancelled. Yeah, they do actually allow you to do this by calculation, even though they've said don't do it by calculation. I'm just glancing at the mark scheme. It says here, yeah, the friction increases basically in proportion to the weight. Basically, as the weight gets heavier, well, the friction gets heavier because, you know, more weight pushing down on it. Okay, so there we go. That's that one. Part D, brick Q is modelled as a particle. Our brick Q is now projected with speed 0.5 down. So it's pushed with a speed 0.5. Describe the motion of brick Q, giving a reason for answer. Well, it's going to initially, its initial velocity and they're trying to tease out some misconceptions here, is 0.5 meters per second, but it will slow down. Oh, actually, no, it won't slow down. this should remain constant. And that's because the forces balance. Almost fell for the misconception myself there. And this should remain constant as the forces balance. Yeah, now this is the old idea. I often put it like this. Imagine a man doing a spacewalk, yeah? And then all of a sudden he gets pushed with a speed of 0.5 meters per second, yeah? The forces balance on him, but he just drifts off at 0.5 meters per second because forces balance when you're going at constant velocity. And we know that forces balance here in this situation. And so, yeah, if you suddenly project with a speed of 0.5 meters per second, the initial velocity is 0.5 and this should remain constant as forces balance, yeah? There's no resultant force down the plane. We're not adding a force. Here's another way of putting it. We're not adding a force to propel the object down the plane. Oh, this is getting worse. And that should score some marks. Let's have a look at the mark screen. Brick Q slides down the plane with constant speed, no resultant force down the plane. And so, yeah, and once again you can do the calculation if you really want to get the marks, so feel free to do the calculation on those questions. In many ways it's slightly easier, I would say, just trusting in the maths. And that's that question. It's a bit of a weird one towards the end, I admit, but yeah, that's how you do it without the calculation, but it's perfectly acceptable apparently to do the calculation. Okay, hope you hope you found that useful, and best of luck in the exam.